So maybe you've mastered those simple 2, 3-step, multi-step equations, but now you're ready to learn about some more techniques for solving linear equations. Well, in this video, I'm going to go through some that have fractions, some cross-multiplying that we're going to do. We're going to clear some fractions. I'm going to show you that technique, as well as having variables on both sides and all kinds of things. So I've got about 6 or 7 problems lined up for you, so let's get to it. So I've found that students are often pretty anxious whenever they have a fraction in a problem. So I'm hoping this video will clear up some of that anxiety for you, so you can just attack them with the process and do the same process every time. So let's look at this first problem. It's 1/3 x plus 2 equals 5. Now, this is a multi-step problem, right? We're going to try to get x all by itself, so we got to get rid of the 1/3 and we got to get rid of the 2. Now, how are we going to go about doing that? Well, probably the first thing I would do here, of course, is to minus 2 on both sides. And I get 1/3 x equals 3. Now, I want to get rid of that 1/3. You do not want to write this on your paper. We don't want to divide. I know division is the opposite of multiplying, right? It's the inverse operation, but we don't want to divide by 1/3. Look how confusing that would be. So I'm not going to do that. Instead, the trick here is we multiply by the reciprocal, because when you divide fractions, you multiply by the reciprocal. So let's do that. On this left side, you're going to see me multiply by 3/1, and whatever you do to one side, you have to do to the other. So I'm going to multiply by 3. These 3's cross-cancel. You're going to see me doing a lot of cross-canceling today. Those 3's cross-cancel, leaving x equals 9. And there's the answer to the first problem. So often you want to multiply by the reciprocal to cancel out those denominators. Let's look at number 2 here. No fractions here, but a lot of stuff going on, right? I see, this 4 right here is just kind of hanging out, so it's going to have to wait until after we do the distributive property. I see the middle of the problem is right here, and we've got more good stuff on this side. Let's take a look. We have a -6 that we have to multiply before we combine it with this +2. So please don't do 2 minus 6. You can't do addition and subtraction before multiplying because of order of operations, as you know. So let's go ahead and do our multiplication of the distributive property. We get 8x minus 4. This 4 is just going to chill here to this next step. The 2 is also waiting for the next step. And now let's multiply the -6. Don't think about that as subtraction. We are multiplying the -6 into this binomial, into those 2 terms there. We get -6x plus 12. I call that the danger zone. A negative times a negative is a positive. So be very careful there. Always check your work. Now I see some like terms, so we're going to combine like terms. This -4 and that 4, oh, this is nice, that adds up to 0. So we're left with 8x equals, and then on the other side, I see some constants, 2 and 12. Those combine to be 14 minus 6x. So here we have variables on both sides. I encourage you to, once that happens, is to deal with that first. And I want you to think about what you want to get rid of. It's a great way to think about this. Think about what you want to get rid of. I would really like to isolate or get the x's all to that left side maybe. So I want to get rid of this guy. How do I get rid of it? Well, just put a +6x. Whatever you do on one side, you got to do the other, remember. So we add 6x, and then they get combined on the left side. So we get 14. Just make sure you do that. Both sides work so that you don't accidentally do a mental arithmetic error. Dividing by 14, x equals 1. Came out very nicely. Okay, let's get to another one. Back to the fraction world here, where we're going to want to get rid of these fractions so we can figure out the answer. Now, I set this up as what's called a proportion. Proportions are where you have one fraction. I'm just doing another example off to the side here for you. When you have one fraction equals another fraction, a great way to solve proportions is by cross multiplying. So this would be 4x and then 6 when you find those cross products. 4x has to equal 6, so x equals 6 over 4, right? Which is 3/2. So that's how you could do a simple proportion. Well, this is a proportion also. It's a fraction equals a fraction. So I'm going to use the same technique. I'm going to take my cross product that way. I'll do it in blue. 3 times the entire binomial, x minus 4, because it has 2 terms. It's called a binomial. The other direction, 7 times x, we write that as 7x. And when you cross multiply, the cross products must also be equal. So if that original equation is true, then so is this red and blue equation. And look how easy that is to solve. I go ahead and do the distributive property like we did in the last problem. 3x minus 12 equals 7x. Variables on both sides. But I don't want to minus 7x because that's going to completely clear off that side. You could do it. It's just going to add an extra step in your problem. Instead, I think I want to get rid of this and get it to that right side. So I'm going to minus 3x. I'm going to minus 3x because I am comfortable with those x's being on the right side instead of the left, equals 4x. Then we divide by 4, right? You've mastered all these simple little tool basics, right? Doing things on both sides. X equals negative 3. X equals negative 3, or negative 3 equals x. So cross multiplying can be used when you have one fraction equals another fraction. If you've got any extra stuff in there, you can't cross multiply. Just like this problem, we cannot cross multiply. So I'm going to show you a really neat technique on the next couple problems on how to get rid of the denominators. Basically, nuke the fractions here. We're going to upgrade all the numbers in this problem to have the same denominator. So what about 6, 2, and 1? What is the least common multiple in those 3 numbers? 6, 2, and 1. Well, if we just upgrade them all to be something over 6, right, then they'd all match. And you're going to see how that's useful here in a moment. So 2 times 3 is how I made 6, so we have to multiply the top also, so 3x. So how do we go from a 1 to a 6? That would be multiplying by 6. So we have to multiply the top by 6. That's 18. Now the left side was already there. So the right side was already there. So there's nothing I have to do there. Now listen carefully. You may think that this looks even worse, right? But all the denominators are the same, so we can throw them away and just focus our attention on the numerator equation. 3x plus 18 equals x minus 4. I have x's on both sides, so I'm going to deal with that now, just like I did in the last problem. 2x plus 18 equals negative 4. I'm going to minus 18 on both sides. I get 2x equals negative 22. I divide by 2. I get x equals negative 11. X equals negative 11. So let me just rehash what I did up top. I decided to make all the denominators the same by upgrading them all to have a 6. So that was my goal. And then I made it happen by figuring out what it took to get there. So that's one technique for clearing fractions. I'm going to show you another technique on this next problem. So here we have 3, 5, and 15. What's the first multiple that they all have in common? 15. So watch what I do this time. We're just, instead of that whole upgrade thinking, we're going to multiply every every term by 15. Every term by 15. 15 over 1. Now earlier I mentioned cross-canceling. So looking at 3 and 15, how many times does 3 go into 15? 5 times. So I'm going to cross those out and put a little 5 up here. I mean, there's a 1 left behind down there, right? How many times does 3 or 5 go into 15? 3 times. So once again, I'm going to cross those out. There I'm going to leave a 3 up top and a 1 on the bottom. It's called cross-canceling, reducing a fraction. And then on the right side, good stuff, really good stuff happens. This 15 cancels that 15 completely. Now, I know this looks like a mess, so let's see what we're left with. We're left with a 5, we're left with an x. I'm going to write 5x. The next part, we're left with x plus 1 times 3. So let me write that like this, 3 times x plus 1. And then on the right side of the equation, we've canceled the 15s, so all that's left is that binomial 3x plus 8. And now, hopefully, it's smooth sailing. See, we've gotten rid of all the denominators. So once again, this is a nice technique for just nuking those denominators. I'm going to go ahead and launch my missiles here. 3x, speaking of nukes, right? Plus 5x equals 3x plus 8. Combine my like terms. I'm going to go a little quickly here because these are some basic skills that you've developed, of course. Combining like terms. If you need a little review on this, I did post a more basic equation solving video that you might want to check out. We're going to minus 3x on both sides. 5x plus 3 equals 8. I minus 3 on both sides. 5x equals 5. Divide by 5, right? We're kind of running out of room here. X equals 1. X equals 1 is our answer. So once again, technique for getting rid of the denominator, but instead of upgrading all the fractions, I identified the least common multiple, and then I multiplied the entire equation by the number 15. And then that resulted in each term being reduced. So instead of having a 15 on the top anymore, we just had a 3 because of that 5, and so on. This is a different type, of course, right? These are decimals, so I want to show you a nice trick on how to do this. Now, this problem isn't too bad, right? You could probably do this in your head with just decimals, but I didn't want to go crazy by putting a whole bunch of decimals on here. Let me give you a technique. Let's get rid of all the decimals, kind of like getting rid of all the fractions. And we could multiply everything by a factor of 10. So maybe multiply everything by 10 or 100 or 1,000. Well, in order to move the decimal point, to get rid of all the decimals, I'm going to need to jump 2 jumps, right? That means 100. So we're going to multiply the entire equation by the number 100. That moves all the decimal points over. And I now have a simple integer equation. I can then minus 125 on both sides. I get 5x equals 75. Divide by 5, x equals 15. So that one comes out very nicely. So we've got one last problem to look at here. This is very intimidating, right? You have a 2/3 on one side, a 3/4 on the other. What are we going to do? Well, let's use the technique that I just mentioned 2 problems ago. Let's look at those denominators and decide what the least common multiple is. So what's the first multiple that 3 and I almost said it. What 3 and 4 have in common? 12, right? I almost said it. So I'm going to multiply by 12 over 1. Multiply by 12 over 1. Now, what does that do for me? Once again, cross-canceling. The skill of cross-canceling is absolute gold, right? It just reduces the fractions, makes all the numbers smaller, which makes the problem easier to do, hopefully, without a calculator. 3 goes into 12. How many times? 4. That leaves a 1 behind. 4 goes into 12 3 times, leaving a 1 behind. Now, because we picked the least common multiple, of course, we're going to have a 1 left behind in the denominator. Notice everything in the denominator is now just a 1. So let's get rid of it. 8, now where did I get 8 from, right? 4 times 2, that's 8. 8 times the quantity, 2x minus 1, equals 3 times 3 is left on the top, so 9, 2 minus x. And then from then out, we just solve it. 16x minus 8 equals 18 minus 9x. Variables on both sides. You know that I like to deal with those first, and I also like to stay positive all the time. Always stay positive if you can. Add 9x on both sides. 25x minus 8 equals 18. I then add 8 on both sides. I get 25x equals 26. Now, you might be thinking, wait, we did something wrong. Nope. This is just how this problem works out. We're going to divide by 25, and this problem came out to be a fraction. So because I showed all my work, I don't have to go to the calculator and find the decimal. I just write my answer just like this. Okay, hopefully this cleared up some confusion on fractions and equations and cross multiplying and clearing fractions and all that good stuff, as well as, of course, variables on both sides. So be sure to like this video and put your comments down below. I look forward to reading them. All right, good luck.